I'm going to be going over how to find all complex solutions, taking a look at this particular polynomial. I'm going to be dividing this up to 3 steps, finding the GCF, completing synthetic division, and I'll quickly go over how to find the divisor. And also, after that, we're going to have to use a quadratic formula to find, again, any complex solution, so which includes imaginary numbers. So again, the GCF. Oh, and in advance, I have really bad handwriting. So in advance, we're gonna have to go ahead and start with GCF, right? And looking at this particular polynomial, the GCF is x. So again, we do want to write down the answer right away just because we don't want to forget towards the end. So what is left here is 2x4 plus 11x3 plus 16x2 plus 15x plus 36. And in order to find the divisor, we have to look at the leading coefficient and the constant term. I'm just so pretty much it's going to be plus or minus 1, plus or minus 2, plus or minus 3, and so on and so forth. I'm going to go ahead and begin with -3, um, but just going to be a pretty much a trial and error to see which one is going to be the root. But let me go ahead and begin. The divisor I'm going to be trying here is -3, so I'm bringing everything else down as well. So we have 2, we have 11, 16, 15, and 36. Let me begin. We have 2, -6, that's 5, -15, that's 1, that's -3, that's 12, that's 30, -36. Now look at this. So because the remainder is 0, I know that it worked. So I know that -3 is going to be the root, right? So we have x equals -3 as the root. Um, and I know that this is a cubic, right? So we don't stop here. We're going to go ahead and continue going, right? Because I want a quadratic. So I'm going to go ahead and use the same exact divisor to see if it works. So let me continue. We have 2 here, so we have -6, -1. This is 3, 4. Oh, excuse me. We have 4 and then -12. So again, it works again. So we have a quadratic here this time though, right? So we do want to stop. And because -3 worked again, our root is going to be -3 again, right? And look at this. We have 2 roots that have -3. So we're going to write our answer down, -3 molt 2, because it was twice. So what do we have left? We have x plus 3 and 2x squared minus x plus 4, right? But we want to continue. We want to continue with our quadratic. So in order to continue, we are going to have to use a quadratic formula. Um, so let me go ahead and begin. So I do want to write down this because this is a, b, and c because we're going to be working with the quadratic. So our formula is x equals -b plus or minus b squared minus 4ac over 2a. So let me go ahead and plug and play here. Um, our b is a -1, so I don't want to write it down twice. Let me go ahead and just leave it 1. All right, 1 plus or minus 1, or excuse me, 1 plus or minus the square root. Oh, by the way, this is a square root. I realized I didn't write it down. I have pretty bad handwriting, and it was towards the top. So, b squared of -1, or excuse me, -1 squared. So what do we know? That's just a 1, right? So 1 minus 4, and don't forget the parentheses here. We have, what is a? That's 2, and then a 4 because of the c is a 4. And um, this is all over 2a, and which is 2 2. And what does this give me? This gives me 1 plus or minus 1, 4 times 2, 8, 8 times 4, 32. So 32 over 4. And what does that turn into? 1 plus or minus negative 31 over 4. And what do we know about negatives and square roots? This is practically where we have to use imaginary numbers, right? So this turns into 1 plus or minus um, I square root of 31 over 4. And again, because of plus or minus, this gives us two particular answers, right? What is our answer here? So we have 1 plus I square root of 31 over 4, and then 1 minus I square root of 31 over 4. So that is going to be our other two answers.